Okay, hi everybody. Today we're going to be talking about the mitosis promoting factor, also called the Cyclin CDK complex, and it's actually referred to by several different names. The cyclin itself, I believe, is the D1 cyclin, but you'll hear MPF standing for different things. I believe it's metamorphosis, mitosis, other M's. But we're generally talking about the same thing. That's going to be the M-cyclin and the CDK complex that it associates with. So let's look at where it is the most active. So we're looking at the green line on this graph, and if you'll notice, during G1 and S, that green line is near the bottom. At G2, it starts to ramp, and the M-cyclin CDK, once it's produced, will positively feed back on itself and increase its own production. That increase in M-cyclin occurs till about the end of metaphase, not about, actually exactly the end of metaphase, at which time it falls off sharply because it's destroyed by a ubiquitinator called APC, or the Anaphase promoting complex. So it's interesting, in G1 and S, E2F, which we've talked about before, which actually drives G1 and S forward, will sit on the promoter to the M-cyclin gene and will inhibit it. So the very thing that promotes mitosis, or the cell cycle in the beginning, will actually inhibit mitosis. Once the M-cyclin is active in mitosis and up through metaphase, the cell will actually arrest in metaphase until mitosis promoting factor has been destroyed. So it's kind of interesting. The E2F, which drives the cell cycle forward, actually inhibits the MPF. MPF will actually inhibit cell cycle even though it drives it into mitosis. And until the M-cyclin is destroyed, that cell will actually arrest, which is the state of many eggs, female eggs, as they're stored. So let's look specifically at how the M-cyclin CDK is activated. So it's going to be activated by 3 different proteins. CAC is going to phosphorylate it to activate it. WEE1 is going to actually inhibit it, and so CDC25 is going to need to remove that inhibitory phosphate that WEE1 puts on it. Now, if you'll look at what activates CAC, WEE1, and CDC25, you'll see many different things. Among them is actually cell size. So several different environmental factors act to regulate the activation of the M-cyclin CDK complex. Once it's made, however, you'll see that it positively feeds